the seminar formally now. So first off, welcome everybody to our Physics Olympiad seminar. We actually have a collection of 4 very talented panelists here who will be talking about their experiences and giving advice on contest physics and for beginners doing contest physics. So before we begin, I'd just like to introduce myself and my other co-hosts. So my name is Victor. I will be hosting and guiding the panelists during this seminar.
And my name is Harry, and I'll also be hosting and guiding the panelists during this seminar.
So now that we actually started, I just first like to talk about this project, Canadian Physics Society as a whole, and why we're hosting this event.
So, who are we? Well, the Canadian Physics Society is an independent youth-led project that aims to streamline physics education across Canada. And one note is that we're not endorsed by or endorsing any tutoring services or schools, because ultimately our goal is to get more students to be interested and engage with physics contests in Canada and not to promote any schools. So not only do we want students to start learning physics, we want them to love and enjoy it as well. Now, why are we hosting this event? Well, that's because physics resources are very, very limited in Canada compared to places like the US or China. And another reason is that schools only start teaching physics in grade 11. And if you want to do contests and actually do well on them, starting in grade 11 is often too late because there's simply not enough time to learn everything while balancing the heavy amount of schoolwork. Also, information about these contests and like how to prepare, how to learn is quite hard to find online. And if you don't know what you're looking for, which is the case for most beginners, you'll likely be very lost. And this is what we're trying to address, not just in this seminar, but with our project as a whole. And finally, like simply put, the physics community is quite small in Canada, and we would like to help expand that and spark the interest of high school students.
All right, thank you for that, Harry. So before we get started again, I just want to give a brief overview of what this seminar is going to look like. So first, we're actually going to talk about the physics contest in Canada, and this is just to give some context to all of you attendees so that when the panelists refer to contests like the IPhO or the CAP, you know what they're talking about. Then we'll be going over the speakers' personal experiences. So this is when the speakers themselves will talk about how they got started in physics and their progression through the past 4 years of their high school. We'll then be talking about more specific issues. So Ethan will then be talking about starting physics contests and advice for beginners. Then we're moving on to CAP and IPhO. This is where Stephen and Jack will talk more specifically about the structure and how to do well on those contests. And then finally, we'll have Eric talk about the CAO and astronomy Olympiads. And this is where he'll be talking about how to do well on them and as well as the structure of those Olympiads. Finally, we'll have a Q&A session at the end of this webinar. This is where you, the attendees, can ask questions through the Zoom function, the Q&A function, and we'll select questions and have these panelists answer them for you. So without further ado, I'd just like to pass it to Harry, and he'll be talking about physics contests in Canada.
So let's introduce some of the major physics contests in Canada, and we'll also be like giving a timeline of when they'll happen as well. So as you can see, all of these contests, they happen in April or May, and that is done to allow for schools' physics curriculums to finish. Now keep in mind, the panelists will go into more detail about the difficulty, the format, how to prepare for them. This just serves as an introduction so that you have more context to understand what they're going to be talking about later in the seminar. Now, to start off, the CAP is the main physics contest in Canada, and it's used to select the IPhO team, which is the International Physics Olympiad. So the top students from the CAP are chosen to represent Canada at the IPhO. Unfortunately, the CAP has been canceled for 2 years in a row due to COVID, but hopefully this year it will be back. Next is the CAO, which is the Canadian Astronomy Olympiad, which also happens in April or May. And similar to the CAP, the top students are selected to represent Canada at the IOAA, which is the International Olympiad for Astronomy and Astrophysics. And of course, Eric will go over more details about the CAO and IOAA a bit later. So moving on, the less major physics contests are the Physics Bowl, the OAPT, and the Sir Isaac Newton contest. However, even though they're less major than the CAP and CAO, they're still very important and they're widely recognized across Canada. For the Physics Bowl, it happens in March or April. The Sir Isaac Newton exam, which is actually hosted by the University of Waterloo, that usually happens in May. And finally, for the OAPT, which is the Ontario Association of Physicists exam, that happens in May. And if you would like to know more information about registration, test format, past papers, etc., feel free to check out our website's contest timeline, where we have gathered all of this information for you. The link is on this slide, as well as in the chat. So I'll be passing it on to Victor now.
All right, so now that we all got out of got out of the way, we're actually going to be moving on to what you guys all came for, which is the panelists. So panelists, why don't you all introduce yourselves? Ethan, why don't you start?
For sure. Thank you so much for having me, and thank you for those attending. I'm glad to be back here with the Canadian physics community. So I go to University of Pennsylvania for engineering, and my physics achievements, I was a qualifier for IOAA for 2020. I was also 2 times IPhO top gold, so that's the British Physics Olympiad. I was 7th in the CAP exam, and for Physics Bowl, I was 1st in Canada for Division 1. A fun fact about me is that I have a little plushie that sometimes likes sitting on my head, and I'm starting to get a little bit of an American accent after being here for 3 weeks.
All right, hey everyone, my name's Steven. I went to Bayview Secondary School for high school and then went to Princeton for undergrad studying computer science. I graduated in 2020. Now I'm doing software at a small hedge fund in New York. In terms of physics, I did Physics Bowl, IPhO twice, the OAPT. I also did IOAA 1 time, but I did terribly. So definitely defer to Eric for IOAA questions. And then fun fact, right now I'm starting to learn the guitar.
Hey everyone, my name is Jack. I'm a AB Duke scholar at Duke University. I study math plus CS and physics. And I went to the IPhO 3 times, 2 bronze and 1 silver. And one fun fact about me is I am in a fraternity.
Hey everyone, my name is Eric. I'm also studying at the University of Pennsylvania. I'm planning to major in mathematical economics. That's basically half math courses, half economics courses. In terms of physics, I participated in the IOAA 3 times. And the last time, which was online, it was technically renamed the Global E-Competition of Astronomy and Astrophysics. I got bronze, and I got gold at the International Economics League.
All right, thank you for that, panelists. So now we'll just move on to personal experiences. So this is where panelists, you guys can talk about how you got started in physics and go basically in more detail on how you got better and how you progressed through the 4 years of your high school. Ethan, why don't you go first?
For sure. So when did I first start doing physics? I think the most accurate answer for that is like since I was really young, long before I knew what physics even was. I think that my first introduction to physics was asking why or how things are designed or why something worked a certain way. I did a couple school projects when I was younger, such as making trebuchet or an RC car or things like that. And I think that was probably what really got me interested in physics in the first place. I would also say that my dad played a large role. He's also an engineer. And so he helped explain a lot of the things. He also helped me build some of my projects. And I think that was a big influence for me as well. I started having the concept of competitive physics in the summer of grade 8. That's when I started really getting more into textbooks and learning it far more academically, in addition to the previous practical things I did. My first physics textbook, the first textbook I learned from was the Halliday and Resnick, and I do recommend that. I think that is a great book. Throughout high school, a lot of what I learned was from physics YouTube channels, things like Bertasium, for example. There's a lot of materials on Google and even Wikipedia. There's some things like NASA sites as well. Not all of it is great, so do have some discretion, but I think that there are so many valuable resources for me, and that's how I maintained interest throughout high school. I think one thing about me is how I observe a lot of these smaller things. So like the small technologies around us, up to like why door hinges are a certain way. If we look at a door, we can see how torque's affected, how forces and how the door's own mass affects it, and so forth. Also asking some questions and always staying curious. I think that's been a big one for me. You see some, for example, cruise ship. It seems really tall. Why doesn't it tip over? What is the physics behind that? Right. So that's the things I look at and really digging into it, even though it doesn't immediately seem to have a practical academic purpose. I think that was great for helping me learn. When it comes to challenges, I think that on contests specifically, the two biggest challenges for me is being able to quickly find a model that works. So when we get a physics question, how do we model it in a way that makes sense and that is mathematically approachable? And the other one is differentiating the scenarios where a certain formula or certain logic is applicable. The simplest example for that in kinematics is if we try to plug in instantaneous velocity into average velocity, that doesn't work. So being careful about the nuances in formulas and the fundamental concepts behind formulas. I think that's a big one. The first physics contest I ever did was the OAPT, and this was in grade 9. So it was almost a year after I started learning physics. And spoiler, I did not do very well. I walked away with that physics contest, no awards, no honor roll, nothing. And I think one takeaway from that for me was actually quite positive, which is that I realized that I knew more than I thought I knew. And I'm going to say that to a lot of the attendees here as well. I think that you probably know more than you think you know. I knew a lot of the ideas on the contest, but some of the little pieces of logic and thought haven't completely connected yet, which is why a lot of the questions I wasn't able to sort through as quickly. So I didn't master the concepts well enough. But I think even at that stage, you already know a lot. And sometimes just piecing those things together, that's going to help a lot. When it comes to confidence in contests, I think confidence has been so important for me. When you see a question, being able to go into it thinking, I will be able to solve this and I can solve it, and seeing there's a symbol I don't understand, it's too difficult. I think the difference between these two mindsets has been a lot of times the difference between solving and not solving a question. Sometimes on contests, you might see a big equation or something with a symbol you haven't seen before. That doesn't mean you can't solve the question. A lot of times read it carefully, and there's a very good chance you'll be able to work through that. So those are my first two pieces of advice, I would say. For a little more specific when it comes to timeline, I started getting physics awards in grade 10. So after OAPT, by the time the next year physics contest rolled around, that's when I started doing, that's when I got my physics bowl and the OAPT awards and so forth. For me, this was a little bit interesting because I was also doing physics C at that time. So I think for a lot of people, they get physics C out of the way first, and then they go into physics contests. For me, I was doing both simultaneously. So that could be quite different. My second piece of advice is that I think I alluded to it earlier, being curious. When we see something around us that is physics-based, and you're like, oh, that's funny. I think that's a great way and a great opportunity to actually look further into it, read up a book, do a Google search, and seeing why something is. All right.
All right, Ethan, thank you so much for that. Our next panelist will be Jack. So Jack, it's all yours.
All right, thanks. Just getting started, how did I get into a physics contest? Well, I guess I just kind of like physics because before I did physics contest, I was reading a lot of physics books, like independent of what I knew about physics contests. So that was kind of like interest, more of an interest thing, less of like I want to get into a US university thing. So that's kind of how I started. I just like physics. And I found it interesting. So my timeline was roughly, I started the summer of grade 8. I learned grade 11, grade 12 physics. And grade 9, I jumped straight into competitive physics. I did not learn any AP physics. Grade 9 went to IPhO, grade 10 went to IPhO, and grade 12 I went to IPhO. So that's a rough timeline of my physics journey. Some advice, tips, studies, resources. Well, I think the advice I would give is do physics contests because you like physics, not because you want to get an achievement out of it. And that's the way at least I see it. And I've seen that people who do that tend to perform better because they actually like it. And they're willing to put in more work to get good at it. And I think that's very important. So yeah, if you really like physics, then I think doing physics contests will help you. But if you don't like physics, I think you need to rethink like why you're doing physics contests. Some study tips. Well, I think people underestimate the power of books. So I really recommend just going through a lot of books. If you're studying physics, also just generally being curious and seeing things online. I think some resources, some books that are good. One is Classical Mechanics by David Morin. The second one is Electricity and Magnetism by Purcell. And the third one is The Physics by Halliday. So I think those three are pretty fundamental texts if you want to study and at a level that's essentially IPhO. As for time commitment, I spent anywhere from 0 to 0 to 60 hours a week during my time when I was preparing for physics contests. So it really depends on what time of the year it is. You know, if it's during the summer, then you want to put in a lot more time than if it's during the school year. It's not, you can be flexible about it, the way I see it. Yeah, I really enjoyed. I think these physics contests are a great opportunity for people to meet other very smart, very hardworking people. I really enjoyed meeting people from other countries at IPhO, and I think it was a very eye-opening experience. So I think I really recommend this this path for anyone who likes physics.
All right, thank you so much, Jack. I think our next panelist is Stephen. So Stephen, take it away.
All right, hey everyone. I started physics or I started contest math when I was in 4th grade. And like Ethan and Jack, I started physics probably when I was in grade 8. And then I did IPhO during grades 11 and 12. So I'm also going to give some advice, which is like, why do you want to do physics? Victor was actually briefing me a little bit before this talk started, and that the CAP was canceled for the previous 2 years, which is a really sad thing to hear because there's a lot of benefits to doing physics contest. So I think one of the main ones you get out of it is like you learn how to solve really challenging problems in creative ways. And so how that translates. So as you're studying for physics contests in high school, you'll probably be ahead for your math and your physics classes. So that's like, that's like one direct benefit right away. You'll also be ahead for most likely first year of math and physics in university, and maybe second year, depending on how much you studied. It also helps with job recruiting a lot. So for example, when you're in university and you're in first year, you often want to find an internship, but you don't have that much experience. And so having a physics contest on your resume will often help with that. Recruiters look for those things even beyond first year. There are some events that I've attended, especially like I would say in finance, where the only reason that they reached out to me is because they've seen that I've done IPHO before. And so like the physics community and the math community is definitely there, and that's something that helps. Related to that, I also did OAPT, and at one point, I'm not sure if this is the case anymore. OAPT, if you win OAPT, then you get to do a research internship with someone at York University, but you get to do research. And so that's like a really cool experience to have. Like Jack mentioned, you get to meet a lot of interesting and like great people. I actually met Jack when we were doing IOAA together. Not IOAA, when we were doing IPHO together. So there are a lot of benefits. But also to reiterate what Jack said, like I think parents often see IPHO as like a way to get to a US university. And I think that's like not a bad direction to aim at, but I don't think that should be your end goal. Hopefully like doing physics and doing contests ultimately give you like a chance to develop a good and healthy work ethic, which will serve you for the rest of your life. One thing that I wish I did differently was like before like a physics class, I would often cram all my homework at once. And that would often make me a little bit stressed out and just like not enjoy physics as much for the physics. Sort of like what Ethan was saying, like I ideally would have like stayed curious and just like enjoyed the physics component because it's a beautiful science and it explains the world. So yeah, that's definitely one thing. In terms of like advice for if you're like younger, like before you started high school, or even if you're already into high school, my best advice for doing physics at the Olympiad level or just contests in general is to start early. You'll be able to see if physics is something that's right for you. And then if you do really enjoy the subject, then you'll have a chance to get a head start on high school physics, first year university physics, as well as like the calculus that you'll need behind it. Yeah, that's it.
All right, thank you for that, Stephen. And last but not least, our final panelist is Eric.
Okay. Hi, everyone. So I'll preface this by saying that my physics journey was very unorthodox, and I don't recommend it because I tried to do astronomy and astrophysics without having the physics background that I should have had, and that made things very difficult. But I'll give you a timeline. So in about grade 8, I had a pretty strong pretty strong math background. I did some math contests, but I didn't really know much physics or astrophysics. And I think my mom knew a friend who had a friend who was teaching a class. Anyways, I went to this class about astronomy, and it was pretty confusing, but I was so interested, like the stars and everything in space and how it worked. And once I sparked that interest, I knew I just wanted to continue learning it. So I started studying just with some textbooks and going to these classes. I started studying a bit of physics and a bit of astrophysics. And in general, I'd recommend if you're actually studying for the Canadian Astronomy Olympiad, you should probably know at least AP Physics 1 before you start studying all the astronomy. But I was just learning it as I went along, so it took me a while. And yeah, in grade 10, or no, in grade 9, I qualified and participated in the IOAA. And then again, another time. And then in grade 12, I got the bronze medal. So I learned AP Physics C only in grade 11 before the third time. So the first 2 times I was going in with not complete physics knowledge. And I think that held me back. So if you're interested in learning astronomy and astrophysics, learn physics too, and math. So in terms of time commitment, some people were spending an insane amount of time. I was generally interested in it for a long time. So I was spending maybe a few hours per week, up to 5, and just doing that consistently over the course of years, since grade 8. And I would just read textbooks or articles or whatever possible to just amass enough knowledge about the subject. And then over time, I just built an intuition for it. And I think that method it's sometimes hard to plan ahead like that, but if you can, breaking it down into smaller pieces is a lot better when you're studying. So I actually, as I said before, I'm probably studying economics, and I switched into the International Economics Olympiad for this summer. And I want to say, build on to the fact that everyone before was saying you should like physics if you're going to participate. That's 100% true. Like you need to be really interested if you're going to be putting that amount of time in it. But at the same time, it doesn't necessarily need to be the thing you're going to major in or the thing you're going to do for the rest of your life. You know, it doesn't have to be your career, it just has to be your interest. For me, physics and math turned me into a better problem solver. I think just the level of training you get in terms of solving problems is insane from physics, and I don't know if you can get it anywhere else. And that has helped me so much in economics too, and in all the other aspects of it. Even though it's a completely separate Olympiad, there's no way I would have done well in the International Economics Olympiad had I not done the IOAA. Thank you.
All right, thank you so much for that, Eric. So thank you to all the panelists who gave their personal experiences. I'm sure everybody found it very helpful, and to have a more personal look at physics and each person's physics journeys. So now that we're finished our personal experiences, we'll now start going into more depth about more specific topics. So the first topic is starting contest physics for beginners. So Ethan, why don't you start with this one?
So let's start with the level of math required. I think that for most of the beginner contests, nothing over high school math, and like I would argue, not even calculus is necessary. So these are contests like OAPT or even probably physics bowl, and at this level of contests, calculus usually isn't necessary. On the CAP, on AP Physics C, of course, on the slightly higher level contests, I would say that calculus is necessary. And if you are pursuing this route of physics, you probably should be doing calculus anyway. Although for basically almost all level of contests, I can't speak to the international physics Olympiad, but to basically all level of contests below that, knowing some really advanced mathematics or like multivariable calculus, that is not necessary. So high school math, I would also point out that I think trigonometry is very important. But this is the level of math that is usually necessary. Be good at manipulating algebra. When it comes to contests, I think that it is both all right to start with some easier contests like I did with the OPT, or you could start with trying to do all the contests but be prepared going into some of them. Some of them, if it's your first contest experience, it will be daunting. But either way, I think that works. So the contests that Canadian students can write, if we go to the next slide, do we have that? Yeah, so the contests that Canadian students can write include the Physics Bowl, OAPT Sir Isaac Newton, and then the Physics Bowl Division 2, CAP, and CAO. We used to have the F equals MA as well, although I think that one Canadians cannot take anymore. Physics Bowl Division 1, and so Physics Bowl is 50 questions. The Division 1, you do questions 1 to 40, and Division 2, you do questions 11 to 50. So there's a lot of overlap, but I think that both of them are, relatively speaking, easier contests to do well on. The OAPT is probably the easiest contest on this list, and the Sir Isaac Newton, I think it gets pretty difficult sometimes. So some of the questions might appear easy, but it could take quite a while to do. Physics Bowl is all multiple choice. OAPT is all multiple choice, and Sir Isaac Newton usually I think has like 12 questions-ish. It is also multiple choice, but they do require you to show your work. So you write down your work and you will send your work in as a PDF file or something along with the contest. I will leave CAP for the other panelists to speak about. Let's go back to the previous slide. So yeah, when it comes to prerequisites, the starting point, grade 11 to 12 physics, you could probably do something like the Physics Bowl Division 1 or OAPT just on day school physics knowledge. The knowledge is there. There would be some contest tricks that are involved, but most of the knowledge is there. AP Physics 1 and 2, that does become more algebra based. And AP Physics C, usually the AP exam itself is easier than, let's say, the AP Physics books such as Halley and Resnick. But these definitely use calculus, and I do recommend learning calculus before doing AP Physics C. I didn't do that, and it was a bit of a struggle. I do recommend doing that.
All right, thank you so much for that, Ethan. So now that Ethan has talked about a little more about starting contest physics, we're actually going to go more in detail. So first contest specific topic we're going to talk about is the IPhO and the CAP. So Stephen and Jack, why don't you take it away?
Yep, so Jack and I are going to talk about IPhO and CAP. So I'll start with the CAP, which is the exam that you write in order to qualify for IPhO and the Canadian physics team. So the structure of the exam, and you don't have to take notes, this is all online, you can find it. The structure of the exam is it's 3 hours and you have 25 multiple choice questions and 3 long form questions. And so one interesting thing is that if you're if you don't get enough multiple choice questions right, usually roughly around 20, but depending on the difficulty of that year, they will not mark your long form. And so you really have to, like, when you're practicing, make sure that you hit that 20 question threshold or higher. Otherwise, like, you could have like perfect answers for long form, but unfortunately they won't grade it. And then, so that's the exam. For years that there's more physics funding, the top CAP writers will then go to UBC for a physics sort of like boot camp where there's more rigorous like testing, and then they pick the top 5 students from that boot camp. It's a great experience. You'll get to meet people and also visit UBC. But sometimes when money is more tight and they don't run the boot camp, then they'll just pick the top scores from the CAP exam. And sometimes, they'll basically pick the top 5 from the CAP exam, and that's how you qualify for IPhO. In terms of the difficulty of physics and math, I would say that if you have a good understanding of calculus, as well as first year physics, so that fundamentals of physics by Halliday that we've all been talking a lot about, you should be ready for this contest. And I will hand it off to Jack for IPhO.
Thanks. So for IPhO, I think it's a very it's I see it as a it's something after CAP, but like when you prepare for physics contest, I think really if you really want to do well, I think it's more important to prepare for both rather than just the CAP. And I think the reason for that is because if you do well at the CAP, there's also something after. It's not the end all be all. So as for IPhO, a couple of areas. So I think really IPhO expects about a second to third year level college like college level physics, with the exception of things that require linear algebra. So as for prerequisite knowledge, I think it makes sense to at least do classical mechanics by David Morin and electricity and magnetism by Purcell. So electricity and magnetism and classical mechanics are very important and very fundamental subjects that you should have a very good understanding of by the time you go to IPhO. There are some other topics like optics, quantum mechanics, thermodynamics. Those are all important, but I don't recommend any specific texts for them because they tend to go more into the concepts, less into the type of problems that you would expect on an IPhO contest. So I recommend mostly working on problems and just looking at things ad hoc for those topics. Now, unique aspects of the competition. So yeah, there is a experimental section for IPhO, and it's really unfortunate that most Canadian students don't really have a chance to prepare for them. In that, for example, for me, there was not a lot of lab equipment at my school. There are ways to work around it. Like it doesn't mean that you kind of just fail the section. It just means you have to put in more work yourself to look online on how to do experiments, and you have to proactively seek out resources at probably local universities or other places that have very advanced labs that you can also use. Some resources, advice, pitfalls. I feel like for IPhO, if you want to do well at IPhO, you really have to put yourself in a situation where you feel like you're actually doing it. So that means you don't get to take break. Like if you're gonna practice for a test, like do it in 5 hours straight. Like no eating, no whatever. Like just very real conditions, and also realize that if you go to IPhO, you're probably gonna be operating at about, at least for me, it's like 70 to 80% of my what my optimal level is. So just be prepared for unideal conditions. So for example, in 2017, they actually delayed theory experimental by 1 day, and it was like, and some people got the wrong translations of their tests, and it was a whole thing. But just be prepared for that because it's not like it won't happen.
A bit to add to what Jack said about the experimental section. Yeah, it's unfortunate that we don't have great training for the experimental section. Like Jack mentioned, you should probably reach out to a university as well as like even your high school physics teacher, see what they can do in terms of like have you practice experiments and use equipment and things like that. And also if you do end up getting to that stage, like you qualified for IPhO and you want to get experimental help, like feel free to reach out to me and then we can talk about it. Yeah.
All right, thank you guys for talking about IPhO. Thank you, Stephen, for even offering the help. I'm sure he will appreciate it. Yeah, so that was basically it for IPhO. Now we're going to actually move on to the Canadian Astronomy Olympiad and astronomy competitions. So Eric, it's all yours.
Okay, so the way the astronomy Olympiads work is there's the Canadian Astronomy Olympiad, and usually the top 5 scores are then invited to the International Olympiad of Astronomy and Astrophysics. The Canadian Astronomy Olympiad is 6 problems. They're long questions. You usually have around 3 weeks to do them. And you can write up or type up your solutions and send them back. So with these problems, they're usually testing the theory section, and I'll get to the different sections of the IOAA, but they're the theory questions. And I would say there's a lot of stuff that you need to know when you're preparing for the IOAA, a lot of material. So, and you have 3 weeks to do the CA. So it's okay not to know something and to look it up as you're doing, look up more of the, I mean, you won't be able to look up the answer, it's not online, but you can look up all the prerequisite knowledge. So so you can study for it, and you won't be able to just start it with no studying, but at the same time, it's okay if you don't know it. With the IOAA, it's split into 3 parts. There's the theory section, and that's just your typical physics questions, but about space. Those are like celestial mechanics questions, stuff like that. And then there's some unique topics like spherical trigonometry, and that's just, but they're all theory questions, and that's stuff you get more training with if you qualify. And then there's the data analysis section, and this is the most like what astronomers actually do, because with data analysis, I mean, real astronomers don't get nice values like here's a mass of a star, find its distance, right? They just get data from their telescopes and their tools, and they have to use computational techniques to sort through them. So in the data analysis section, you're basically applying statistics to astronomy. You don't need to actually study statistics very much, because the statistics is very basic, but you still are using these techniques of sorting through data and trying to get results from that. And then there's the observation section. So the observation is you literally using a telescope to observe stars, or you're given paper with star charts and you have to answer questions or fill in constellations, or you're in a planetarium and then you have to answer questions about the stars you see from that. So with the observation section, it's really a lot about memorizing the constellations and the various celestial objects. That's not something you need for the Canadian Astronomy Olympiad, but it's very important in the IOAA. So if you are prepping for the IOAA specifically, you probably need to start early memorizing these. But I think anyone can do it. It's just a matter of how much time you're spending. So in terms of resources and advice, I would say your best resource is our textbooks. I don't know the specific ones I used because it was a while ago, but any sort of textbooks you can find, physics textbooks, astrophysics textbooks. Like a couple of years ago, I was talking to Jack, and Jack was, you probably don't even remember this. I was asking him, what are the best ways to study? And Jack was like, you should use textbooks. Textbooks are much better than videos. I like them more. And I was like, no, why would you want to read a textbook? Just watch a video and have the material presented to you so nicely. I didn't say that. I was just like, okay. But since then, I've really learned to appreciate it. I think sitting down with a textbook can give you a much better understanding of the material. And everyone has their own ways to learn. Learn the way that helps you, but I know that with the IOAA, you may need to read more textbooks just because there are less videos online about astronomy. And at least for me, and Jack, I guess, textbooks have been very good. Some advice I have, basically, you will probably be stuck on a problem and you can be stuck for a long time because there's just so much material you need to know. Sometimes you're stuck on a problem and you don't even know why you're stuck. If you ever are stuck on a problem, and this goes for physics too, it's not because you're stupid. It's not because the problem is bad or something like that. You probably need to come back to it later. Sometimes you're just missing a bit of material, a bit of intuition, something like that. Sometimes you can read the solution and just not get it still. That's okay. Come back to it in a few months or read up more about the background and you'll get it. Thank you.
All right, thank you, Eric, for that. That was very comprehensive. So we're now going to move on to our final section, and this is going to consist of a Q&A session. So attendees, you may send questions through the Q&A feature on Zoom. So if you tap on the Q&A button, you can send questions, and we can offer panelists these questions if they want to answer them. So first, we're actually going to start off with a few questions that we've already collected through your form responses. The first question I want to ask panelists, and you guys can decide who or which people would want to answer this question. So the question is, are there any differences between learning physics in school and preparing for a contest?
I can start with that. Yeah, there are some differences. It's if you've taken like a math contest before, I think the analogy is similar here. It's like you use the same sort of set of ideas and concepts, but you use it in a much more creative way. And that's how, like in contests, even though they say like you're not able, or they cap the concepts that you use to a high school or a first year university levels, they can still come up with incredibly creative and challenging problems. And so I would say in the classroom, you use it more in a linear way, in a more straightforward way. And in the contest, you have to really bridge everything together and make a lot of connections.
I agree. I think that for a lot of day school courses, you could probably get away with just knowing the formulas, how to use them. And you could probably do okay on a test just by memorizing a couple questions. But on contests, you really have to master, even if the knowledge is not difficult, you have to really master and grasp those pieces of knowledge to be able to work your way around the contest.
All right. So thank you, Stephen and Eric. Why don't we answer some of our attendees' questions live? So let's see. Are there any specific topics that come up more often than others? So examples are torque, gravitation, harmonic motion. And if yes, which ones show up the most often?
This depends on the contest, of course, but I can speak to probably the easier contest. I think the OAPT, it is very largely mechanics, and sometimes there's waves or a little bit of E&M. On physics bowl, I think there's a pretty even distribution. You're also going to get thermal and those, and I recall there being some nuclear physics questions on there as well. CAP is also somewhat mechanics heavy, but there is definitely also significant. You should like definitely know the other branches as well.
Yeah, to add on to that a little bit, if there's like a specific contest that you want to write, I would suggest you look through the past contests, and they usually give you a pretty good sense. Yeah, generally for these contests, you need to know like a breadth of everything, but as Ethan mentioned, like mechanics is definitely a focus because that's generally what's taught most in high school. But go visit that contest that you're interested in writing, and then yeah, it'll give you a much better sense.
Thank you to our panelists for their answers. Another question is, how do you balance starting out rather late in competitive physics and doing well in school and other extracurriculars? So how would you also balance your time?
I'll take a stab at it. It's tough. Being in high school is actually really, really hard. I talked to my friends in university, and now I've graduated after university, and we're all like, yeah, high school's like probably the most stressed out we've ever been, even compared to in university. In terms of, let me see what the question is again. Oh, okay. So doing well in school and competitive physics, potentially those go hand in hand, like you study for physics and it'll help you with the physics classes you're taking and the math. But in terms of that and extracurriculars, that is just, I think, like you prioritize the extracurriculars that are the most important to you, physics being one of them. If physics is your top priority, then you should probably dedicate more time. And if it's not, then yeah, do whatever extracurriculars you feel like is the most important, and then try to fit in as much physics as you can with the remaining time.
I agree with that. I think it's important to really think about what extracurriculars are most meaningful to you. And even in some cases, even if it might be, it might not feel right or might be difficult to drop something, you have to make the decision. If you are getting like way too overwhelmed, way too stressed, and you're not getting like anywhere near enough sleep, then that's, I don't think the health trade-off is worth it, right? So have clear goals and clear priorities. I think that's the best advice I can give.
All right, thank you. So I guess we'll move on to another question. So let's see, which grade math do we learn before we start to learn physics? So I guess what are the math prerequisites that we might need to learn before delving into contest physics?
I think I'll take a stab at this one. So I think you just need grade 11, grade 12 math. That's in my opinion. I started physics without taking AP calculus or AP physics. I started physics contest without taking AP calculus, and I think it's possible to learn as you go. But and I actually recommend it that way because sometimes in math, they give you a concept and they don't tell you what it's used for, or they don't motivate the use for it. But if you're doing physics contest and you find that you have to use this mathematical tool, then you kind of just, you feel like you need to learn it, which actually helped me learn better. So that's the way I would recommend it. But I know I've known people who have finished AP Calculus C or BC. Overall, I think the general idea is to have a good grasp of derivatives, integrals, and solving linear differential equations. I don't think there's much more to it than those three things.
Eric, having participated, I guess, in astronomy Olympiads, how do you think like the math is different from, I guess, just your general physics Olympiads?
I would pretty much agree with everything Jack said. You don't necessarily need calculus. Technically, you can get by without it, but it'll help you. So start with knowing the math up to calculus, and then just go solve the problems. And if you don't have the tools, learn them as you go. Eventually, you'll get to calculus. It'll be a little easier.
So for astronomy, I think I know that spherical trigonometry is one of the more rare concepts you'd see in physics, but you would do in astronomy Olympiad. So how or would you learn astronomy, spherical trigonometry?
Yeah, that's a really tough one for most students. Again, this is not something you typically like learn beforehand, just because you're thinking you're going to study physics, so you start learning spherical trigonometry. That's so specific that's something you would probably learn as you encounter. So you see it, you know you need to know it, or you're qualified already, and you see that that's something you're going to need to know. And I'm not sure the specific resources. It's rare enough that you're going to need some textbook. You're not going to find too many like online resources or videos on it. And just at that point, get a textbook, read up on it a little, do some practice problems, and then come back to your physics and start applying it.
All right, thank you for that. Harry, you want to lead the next question?
The next question is it practical to aim for IPhO if someone has just started learning content physics? And the follow-up for that is, I guess, how long does it take to get to an IPhO level?
I think I can help answer that, at least address that question. I don't think it's practical to aim at IPhO when you start physics contests. I don't think it's a bad goal. I just think it's a little bit unreliable of a goal because there are many factors that could affect whether or not you go to IPhO, even including the pandemic. So it's very easy to, at least for me personally, I didn't aim for IPhO. I just like doing the stuff I was doing. Like I just liked physics, so I just kept learning. And then eventually you get to the point where you're good enough that you just make IPhO anyway. And that's, I feel like, the best route. It's you enjoy it more, and also you don't stress out about it as much. And frankly, I think if you become good enough at it, like making IPhO will not be a problem, in my opinion.
Thank you, Jack, for your answer. Another question would be, has there ever been any periods of time where you felt like you were stuck and not improving? And how did you overcome that?
I think I can help answer some of that. So it really depends on your definition of stuck, because it could be on a single problem or it could be on a category of problems. And there's different ways of being stuck on a category of problems. So one way I think is math. You're stuck on the math. You don't know what the math means. You don't know how to use it. In that case, I recommend just learning the math. You could be stuck on the concepts. So you never had exposure to those concepts. You don't know what the intuition is. You don't know how they tend to generally work. So in those cases, I recommend just being curious and looking at things online. Also, textbooks help a lot, but more so just online, just browsing generally. Like what are these phenomena? Like why do they happen? Like what are the fundamental laws associated with them? I think that's helpful. And another way you could be stuck might be creativity or experience. So if you haven't practiced enough problems, then it's likely that if you encounter a new problem, you will not be able to solve it. So in those cases, it's really dependent on the amount of problems you solve and also your creativity, which I think is something that you kind of get from other means. But yeah, I think those are those. If you get stuck in those three ways, those are kind of the ways you can go around it.
I'll add a little bit to that. Yeah, definitely felt stuck. Did like contests for a while, and there were certain points where I think I was just like a little bit burned out by contests in general. And my suggestion for that is just to try to do it in a more sustainable way. When I was in high school, I didn't really work sustainably. I just like pushed a lot of things to the last minute and then try to do it all at once. And I was like stressful, and procrastinating also felt bad. And so I would suggest like you try to spread it out, do a little bit every day and get it done that way. And hopefully that'll allow you to slow down, enjoy physics or math or whatever it is that you're doing. And also like be curious and see the bigger picture.
All right. So yeah, I guess another more unique question we have is, are there any chances for high school students to work with university to do research on physics?
Yeah, great question. I think I tried to do this. I wasn't super successful cold emailing, although I have heard of people who've been more successful at that. One thing I would suggest is, like for example, OAPT. It used to be that if you got first place, then that was the prize. Like you got to do research for summer. So look and see if OAPT still does that. Otherwise, yeah, I'm not super sure. If you're doing physics at a high level, like getting ready for the Olympiad, then maybe reaching out to your high school teacher, or maybe just like, I know at the University of Toronto, they have a physics department that's kind of like linked with the CAP IPhO. So you might be able to reach out through that way. Yeah, I don't have great advice for that though.
I think adding on to Steven's point, code emailing will not be easy because physics does expect a base level of knowledge for you to be operating at an effective level. I think part of it is to set realistic expectations. No one's expecting you to, if you can do it, it's great, but no one's expecting you to contribute original research as a high school student. And knowing that means you target opportunities that are more suited for your level. So if you know a lot of college level physics already, great, then you probably know what level of research you want to get into. But if you don't have a lot of experience, it might make sense to target something a lot more basic, even just like not even doing research, maybe just reaching out to university, like, hey, can I work in your, like, can I like use your lab or like participate in a course you have, and then go from there. That's what I think is a way to go about it.
All right, Harry, you want to do the next few?
I see anonymous attendee asking, we are in grade 9 now. Is it too late for us to start? I think I don't think it's too late to start. If you are interested in physics, I think many of us started in the summer of grade 8. Grade 9 just started. We're not even a month in. I don't think it's too late. There are still definitely plenty of opportunities. You still have 4 years of high school, essentially. So no, I don't think it's too late to start. And even if you're not in grade 9, even if you're like grade 10 or 11 or so forth, I don't think it's like, if you want to do contests, we're gonna look at this differently from if you're interested in physics, right? Because if you're interested in physics, you can start anytime. I know people who have never taken a physics contest in high school and are here at uni taking physics classes, even doing a physics major, and they're doing great. So I don't think it's too late to start physics. If we're talking about physics contests, the more time you have, the better. But definitely, no, grade 9 is not too late.
Yeah, I really want to add, yeah, like I think Ethan's point was really great. Like if you're interested in learning physics, it's never really too late to start. If you're interested in learning contests, it might be different because you're restricted to a timeline of, end of high school, which is something that's a practical concern. So yeah, I think there's 2 ways to go about it.
Thank you, Jack and Ethan, for your answers. This question is about IOAA. So let's say you're good at competitive physics and you do well on things such as the CAP, and perhaps you're on the level where you can qualify for the IPhO. Like, would it be easy to switch over and do the IOAA and the CAO? And like, how much time do you have to spend to like transfer and like learn the new astrophysics knowledge?
I can give a little bit of background on this because during my year, they basically, I think maybe they still do this, but they gave us an IOA spot because we did well in the CAP and we didn't get that much training. and I did terribly. And so that is to say, you definitely need some IOAH specific training. In terms of what that is exactly, I would defer to Eric, but I think we probably had like a month or two of training, and that was not enough.
I just like to add one quick thing. I think getting into IOAA, at least with how physics currently is in Canada, within a month or two is entirely feasible if you're already at that very high level in physics. But doing well in IOAA, that's a whole other story.
I think I've had a little bit of like, experience in both the IOAA and IPhO, just like Stephen. And I think the way I see it is IOAA is not there's really I think for me at least the areas that are really different are the coordinate systems, the memorization, and also certain like I think just those two. So when I was preparing for IOAA, what really stuck out to me was there's a lot of conventions that they have in astronomy that are very much related to like how do we actually like very practical things, like how does a telescope work, or like how do I see things from if I stand on Earth. So those conventions are things you're going to have to work with and probably struggle with if you get into IOAA from physics. And also you're going to have to know a lot more of the constellations, which have no intuitive sort of backing. Sort of you just have to know the names or like the stars and which locations they're at, how they are relative to the coordinate systems and other things. And those are the things that I think are very much different from IPhO. And those are the things you need to watch out for if you're doing IOAA.
Another question is that in the years where there has been a training camp after CAP, how is that like, and what did they prepare you for?
That's interesting. I actually met Jack at the training camp. I think it was something like a week-long event. They try to simulate what happens at IPHO. So they give you one or maybe two theoretical exams, each like probably 3 or 5 hours long. And they also have experimental section, which is probably again 3 to 5 hours long. But the whole point is to try to simulate what happens at IPHO. And then they get like and then they combine that, the results of how you do during that training camp, as well as your CAP score to finally determine who makes the top 5. And usually, so it's definitely a more rigorous process than the CP exam, because in general, I would say the CP exam is much easier than the IPHO. So when you have the training camp, it's like a more robust process. And then, in between, they also allow you to explore the UBC campus and maybe have some events so you can talk to some of the other students.
Yeah, echoing just what Stephen said, it's something that mimics the IPhO. It tries to select for people that will do well on the IPhO. So it essentially just tries to mimic it. The experiments are kind of like, they're kind of restricted to university equipment. So they will likely not be IPhO equipment. So they're not gonna have very specialized things, but it's going to be pretty difficult. You're gonna the experimental stuff you're gonna have to know in addition to the theory, which I think is something that is worth noting, especially if you don't have access to a lot of experimental facilities.
All right, thank you. So I think we're gonna go a little away from contests and preparing for contests. We're actually gonna talk about this question, which is what are your opinions on being in a classroom for extracurricular physics classes compared to self-studying, and which methods do you use and what methods do you prefer?
I mean, I think that you should probably, ideally, you would get a mix. In general, I think each learning strategy in general has its own advantages. And if along your journey you use various different ways to learn, that's always the best. Specifically for you, I can't answer that because it's going to depend on you which one you do the most of. But I will say both of them have their advantages, and self-studying really lets you personalize well. So if you're good at self-studying, it's a great route to take. But there's also certain things that you will never get on your own that you need a teacher or students around.
I would say if you're just starting out, the classes are probably good. They'll give you some structure, and it'll reiterate a lot of these resources and teach you physics in the fundamentals in a good way. And then once you get to a higher level, then I think you'll have the background and the understanding to start studying a bit more on your own. And then, yeah, like basically like start in a general class, develop the tools that you need, and then you'll be able to study by yourself more effectively. If you start out studying by yourself, there's the potential that there's just like too much and you might get lost and discouraged and things like that. So I would suggest you start in like a more general, like a class setting.
All right, so thank you for your responses. There's one more question that one of the attendees submitted, and it's about resources online. So I know all of you talked about textbooks and books you use in preparation. This question is more about where can I find resources online on the internet, maybe what databases are there, what wikis are there that can help you with just developing your general knowledge.
If you're self-studying for high school physics, I don't think there's like a big textbook that everyone uses. You're probably fine using some textbook that you learn or study for the AP exams. If you're doing, so then one step beyond that is first year university physics. And the first book that is like a seminal book is Fundamentals of Physics by Halliday. I think we've all recommended it today. It's a great book. And then once you're kind of going beyond that, then I would suggest the books that Jack brought up. So there's the mechanics book as well as the E&M book. So that being said, these are textbooks, and that's kind of how I learned physics. I'm not super sure about videos. I know there was a question about like online, these MOOCs, like the online courses. I haven't tried like the online classes myself, but maybe one of you guys have.
I haven't. So for me, online was not necessarily to build a foundation knowledge. For me, online was interest in like just the things I saw and like, oh, I'm interested in this thing. How do I find the information about it? The most widely available resources online. If you want to completely like get up to contest level or study for an entire course online, I know there are sites that offer courses. I do not have any experience with them. So I can't necessarily speak to like how watching videos or reading something online, how that can contribute to learning physics. When it comes to books though, I do have two with me and I do like them. One of them is the Mathematics Survival Kit. This one, it's all about math. It's high school math. It covers everything from fairly simple algebra all the way to some quadratics and calculus and so forth. I think that most physics contests, mathematics is covered in this book. And another book I'm currently reading is Mad About Physics. This one I think has 400 like just commonly, it's kind of like contest E questions. It doesn't, it's not for a specific contest, and I don't recommend it as contest practice. But it's just an interesting read. And sometimes you read these books and you realize, oh, I didn't think of that. And that's what I recommend that book for. Yeah.
I think in terms of resources, I definitely still think books are the best way to go, but I definitely found a lot of help in online websites and things. So to list a couple, I think one very good one that's targeted at amateurs is hyperphysics. So HYPER physics, hyperphysics. It has a lot of very practical, like little pages that tell you how concepts work, and it doesn't get into too much of the details, and you can kind of explore that on its own. Wikipedia, if you're interested in a concept, Wikipedia never hurts. It's very objective, like it gives you a very good background on how it works, so it's useful when you're relating it to other concepts. And also if you do a Google search for IPhO resources, it's the second result to me. It's IOC.EE. It's a I think a Estonian website. It's an Estonian website. It's maintained by some person, but it has a lot of study guides for IPhO, which it has a lot of really very good PDFs that tell you like what are the concepts you need to know, or just give you really good practice problems. I think those are great. Another source is I think it's very important to do the United States Physics Olympiad problem sets. So useful. I think they are much more well made in the CAP, and they're very they're very smartly designed problems. So I really enjoyed those, and I think those taught me a lot. So I definitely recommend those resources in addition to just textbooks. Yeah.
All right, thank you for that. I just have one more question, and this is just a little more practical. So a lot of people are kind of confused on where to register or how to register for these contests. So in terms of your experiences, how did you register and where did you take these contests?
Okay, I'll start this off as I did run some physics contests back in high school. I think it depends on the contest. Some contests you might be able to take at places outside of school, but if you can't find a certain place to take it, do plan ahead and try to work with your teachers to see if you can get the high school to organize the contest. A lot of the high school teachers have had experience running certain contests, so search them out. Even if you don't take their class, just walk up to them and ask them if they're happy to run a contest for you.
Yep, and to build on to Ethan's point, many times like your physics teacher will be happy to run a contest even if just you are taking it. So don't be afraid to do that. And you never know, like sometimes a contest becomes available and then there's like more people that are interested, and that's also great.
Yeah, so with the Canadian Astronomy Olympiad, you don't need any registration. You just solve the problems on the website and send them. There's an email address that you send them to. So the way you find the website, the easiest way is just to type Canadian Astronomy Olympiad into Google. They'll be there, and the questions aren't live yet. So I think the contest is usually in March or April, around that time. So just look out for, if you check the website every once in a while, they'll be posted and you can solve them and send them.
All right. So Harry, do you have any other questions? Any more questions you want to get out of the way?
I don't think there's any more questions in the chat or the Q&A section. If you have any last minute questions you would like to get answered, please type them out right now and we'll try to get them answered. If not, then we can just wrap up today's seminar.
All right. So as just some final parting words, panelists, what would just be one most important piece of advice you would give to a beginner starting physics? So Ethan, you want to start off and we'll just follow the order?
Sure, be brave and go for it. No, but seriously, in a lot of cases, just saying, I can solve this. I trust myself to be able to work through the mathematics and the physics and that I can learn it. That's been so important. And since we do physics stuff around us, I think a lot of times you will find that you already have more tuition than you previously thought, because physics is quite a combination of what you observe, intuition, and mathematics. If you have a good math background and you try to observe things, I think that's a very good place to be. That's a very good start.
I'm supposed to be next. In terms of if you want to do physics contests, my biggest piece of advice is always just to start early. I think one common theme between all the panelists is like we all started roughly 8th grade, maybe earlier. That definitely helps, especially since, as we mentioned, like high school physics, some high schools you might not take it, and if you wanted to, they usually start in grade 11. So if you start in grade 8 or early high school in grade 9, you'll have a chance to explore, see if it's right for you, and then like build your foundations early. Another thing, if you're taking a lot of contests, is to hopefully do it in a sustainable way, to pace yourself, and yeah, enjoy the subject that you're learning.
I think some final, I guess it would be that the essence of it is more important than the appearance that you're getting it, and also to not memorize. So okay, so the first thing, what I mean is you should be more concerned if you don't understand it and get it right than if you understand it and get it wrong. Because the latter means you might have made a silly mistake or you did something that was more so related to circumstance, whereas the former meant you might be lacking fundamental understanding, and that's a lot more problematic in the long run. So I think try to understand it and not worry about getting it right, because you'll eventually get it right if you understand it well enough. And the second thing was don't memorize. I think having a bad rote memory actually helped me on physics contests, because it meant I never could memorize the solutions to problems. So I had to understand it or else I couldn't really reproduce it. So I think yeah, just not memorizing the solutions to problems is key in doing well in physics.
I would say, don't be afraid to do stuff that may be beyond your level or that you think is too hard, but also recognize that sometimes you need to go back before what you're studying and get a better sense of the background. So a lot of times stuff, it might sound scary. As Ethan said, just go for it. Even if it's a little bit more advanced, try it out. Like immerse yourself in things you don't always understand. Just see how it is. Get a feel for it. Spark your interest. But don't spend too much time working on something that you're not getting without going and checking out the background first.
Yeah, and just one last thing I just remembered. This I think this is really good advice, which is don't be afraid to spend time on a problem, even if it looks simple or easy, or even if everyone else in the class seems to be like they get it and they just use, oh, it's just this formula. And don't be afraid to spend time on a problem. Oftentimes, a lot of problems are fairly nuanced. Even if other people seem to be getting it quicker than you are, like for a lot of problems, it took me forever to actually feel like I understood the problem well. And once I did, I realized I understood it better than everyone else who got it faster than I did. So even if it's a simple problem, don't be afraid to really look into different ways of solving it, the fundamentals behind it, maybe even like read up on like the history of some concepts used or something, but really go for that.
All right, thank you so much. So I think we're going to wrap up our Q&A session today. Thank you to all the attendees who've asked questions, and huge thanks to all the panelists who've devoted their time to answering their questions. So there's one last question that I would like to answer myself, and that is, are there any other events like this? So Canadian Physics Society, it's a project aimed at increasing awareness of physics opportunities for high school students. And this is one of our first events, just to get more people knowledge and more aware of these contests. In the future, we're planning to do host more physics contests, host more informational webinars like these. And yeah, so you guys can all stay tuned at our website, www.can5soft.com. There we have some resources. We have a contest timeline that you guys can check out. And yeah, we also mentioned a lot of the resources and advice that these panelists mentioned today. So be sure to check that website out for more events like these. We'll continuously update it when we have more events for you guys to attend. So with that, I think
real quick, for the people, if they want to get this recording and maybe like some of the books that we've suggested, because there's a lot of comments about that, is there a way for them to get that, or are you going to send them something?
Yeah, so for the people who registered through the Google form and indicated that they wanted a recording of this event, we'll send a video to that email. So check your inboxes for a recording, and you guys can reference back to this recording anytime you want. So with that, I think that finishes.
Just to add on to that,
yeah,
we'll probably also be posting this recording on our website a bit later. Be sure to, if you haven't registered through the Google form, you can find the video on our website. And also for the resources and books that were mentioned here, we do have a pretty comprehensive beginner guide on our website as well as the physics timeline and the physics opportunities in Canada. So feel free to check out that as well. And I'd like to thank all of the attendees for coming today, and huge thanks again to the guest speakers.
Yeah, thank you all, Stephen, Ethan, Eric, Jack. I know you all have very busy schedules, so thank you for taking the time out of your day to come here and share your knowledge and expertise to all these participants. And so with that, that's enough plugging our website. I'm going to end the meeting now. Have a good day, everyone. Bye.